Now we're going to talk about the inverse of a matrix. The reason we study an inverse is because in our equations above, it's great that we have equations, but we want to figure out how to solve for these variables x, y, or x, y, and z. To do that, we use the inverse. Inverse lets us undo the matrix multiplication. So essentially what's happening is if we have A, some matrix, times our matrix x, y, we know that equals a matrix B. The way we solve for x, y is we take the inverse of A times matrix B. That's how we move matrix A to the other side. We use its inverse. The definition of an inverse of a matrix is a matrix such that the inverse times the original matrix is the identity matrix, or the original matrix times the inverse is also the identity matrix. And again, this is where A to the negative 1 means the inverse of A, and I sub n is the identity matrix. For some quick reference, your identity matrix is going to be a square matrix. It's always written I sub some number depending on what its dimensions are. So for example, I sub 2 is a 2 by 2 matrix that has a diagonal of 1s and 0s everywhere else. We can sometimes write the identity matrix as just I if it's very clear what the dimensions are. So then I3 is going to be a 3 by 3 matrix with a diagonal of 1s and 0s everywhere else. I4 is a 4 by 4 matrix with again a diagonal of 1s and 0s everywhere else. This pattern continues such that IN means that we will still have this diagonal of 1s and 0s everywhere else. And this is an n by n matrix. So I4 is a 4 by 4 matrix, I3 is a 3 by 3, and I2 is a 2 by 2. There's a very good reason why we need to know these identity matrices, and it's because using the identity matrix is how we find the inverse of a matrix. For this first one, I'm going to just set you up with an example. You're more than welcome to try it with me if you want to, but then we'll look at another example where you can try it on your own. But this is the general steps for finding the inverse of a matrix. Let's assume I gave you the matrix A, and that matrix was 2, -1, -3, 2. The first thing you want to do is set up this system so that you have your original matrix on the left, line, an identity matrix. You're then going to use Gauss-Jordan elimination and turn your original matrix into an identity matrix. Altering these numbers on the left will inevitably also alter the numbers on the right. What you end up with on the right will be your inverse matrix. Let's see what this looks like. Alright, so I want to get my numbers on the left to be 1, 0, 0, 1. First thing I'm going to do is I want to flip rows 1 and 2. So this gives me -1, 2, 0, 1, and then in the bottom 2, -3, 1, 0. Make sure that whatever you do on the left side, you also do on the right. Alright, next I'm going to multiply through R1 by -1. This gives me 1, 2, 0, -1, or 1, -2, 0, -1, 2, -3, 1, 0. Right, now I'm going to use this 1 to make the number below it 0. So I'm going to take -2 times R1, add that to R2, and that will be my new R2. This gives me 1, -2, 0, -1. -2 times 1 is -2, plus 2 is 0. So I get 0, 1, 1, 2.